All right, my dear geometry thugs, we finished up chapter 7, and now this is the chapter 7 review. It begins on page 302 in print, and in volume 28 of your Braille copy, it's on page 302 straight up. It says chapter 7 study guide and assessment, and as always it starts out with understanding and using the vocabulary. There's only 3 vocabulary words or phrases in this entire section. It was a very short chapter. And these 3 words would be exterior angle. So if you recall from your lesson on exterior angles, that those are the angles that are on the outside of your triangle. There's several of them there's 2 at each vertex that are on the outside of the triangle, and they have some very important qualities. They equal the sum of their respective remote interior angles, those 2 angles that are on the interior opposite that exterior angle. Or you can go about getting the measurement of an exterior angle by using your linear angle theorem and your angle sum theorem for a triangle. Inequality is the next word. You've been dealing with inequalities for quite a while. That's the less than and greater than kind of information. There's a big review on that, but just putting it to use with triangles and reading it and using it with angles and measurements of sides. And then with this last section, with realizing that the triangle inequality theorem, you have to have 2 sides that add up that are greater than the third side. So you use that symbol to show that. And then the last vocabulary word is remote interior angles, and that was already just mentioned a little bit ago. The remote interior angles are the 2 interior angles that are opposite its respective exterior angle. So each exterior angle has 2 remote interior angles that are the opposite. They're not sharing, the 2 angles that are not sharing, not in a linear pair with that exterior angle. Then number 1 through 10 is you need to determine whether each statement is true or false. And if the statement is false, replace the underlined word or phrase to make it true. So number 1 asks, the expression 4y minus 9 is less than or equal to 5 is an example of an equation. And that would be false, because that less than or equal to sign makes it an inequality. It's an example of an inequality. Even if the less than equals, it's got the equals there, but because of that less than, that inequality symbol, it's an example of an inequality. Looks like an equation, it acts like an equation, but it is an inequality when you get your answer. Number 2 says, in figure 1, angle 3, 5, and 8 are exterior angles. So we got to look at figure 1. It's on the next page. We have a triangle with sides that are extending with arrowheads and points outside of them. At the very top vertex, they've labeled it K to the right of it. And if we go from about 11 o'clock to 5 o'clock along the side, we go to, it's an arrowhead, but just before the arrowhead it has an intersection point and a vertex D. They're labeling just to the upper right. And then you move immediately to the left from 9 o'clock to 3 o'clock, and you get to another vertex point. It does head off into an arrowhead, and that vertex point they're labeling A at the very bottom. And then you go back up to K, and that's the outline of your triangle. And then notice that the sides are extended. So that side AK is extended, and it has a point up there, point B. And then on the right hand side, it's both extended in both directions, creating a line headed into infinity with those 2 arrowheads. And then same with the base. They've extended the base with 2 arrowheads. And then where there's interior angles and exterior angles, they've labeled them with numbers. So the interior angle, starting at the top, we have 8, the bottom right is 3, and the bottom left is 5. On the exterior, starting at the bottom left, there's 4, and then up at the top, there is 6 and 9 that they've labeled. And then at the bottom right, they've labeled an exterior angle at 7. Right? So they're asking you, or they're saying 1, 3, in figure 1, 3, 5, and 8 are exterior angles. True or false? So you find 3, 5, and 8, and that would be false, because what kind of angles are 3, 5, and 8? They're interior angles. Number 3 says CM is greater than or equal to BQ, means the length of segment CM is less than the length of the segment BQ. Well, the way we just read it with that symbol greater than or equal to, it is not less than. That's false. It's greater than. Number 4 asks, a remote interior angle of a triangle is an angle that forms a linear pair with one of the angles of the triangle. That would be false. An exterior angle is an angle that forms a linear pair with one of the angles, interior angles. Number 5, the triangle inequality theorem states that the sum of the measures of any two sides of a triangle is greater than the measure of the third side. And that would be true. That was just discussed in 7-4. And number 6, it says in figure 1, so we're looking at this figure at the top of your Braille page again, the measure of angle 7 equals the measure of angle 5 plus the measure of angle 8 by the interior angle theorem. So we go find angle 7, and we go, oh, okay, that's an exterior angle, and 5 and 8, oh, those are two interior angles. Oh, those are the remote angles. That's right. We have to add those up to equal 7. However, this is tricky, because this is false, because the theorem is actually the exterior angle theorem. So the math is right, but it's a false statement because they said the interior angle theorem. We got to talk about the exterior angle theorem here. Turn your Braille page for number 7. It says the measure of angle Z is less than the measure of angle Y, means the measure of angle Z is less than or equal to the measure of angle Y. This would be false, because all it is less than. If it had an equal sign with it, then it would be less than or equal to. Number 8 says in figure 1, the exterior angle at K, the exterior angles at K are angle 6, 9, and BKD. So if we go back to our drawing, back a page, at K we have 6 and 9, and then BKD. Well, that's false, because we only can have 2 exterior angles at any interior angle, and it has to form a linear pair. So number 6 does form a linear pair with number 8, and BKD forms a linear pair with number 8, but angle 9 is not an exterior angle to number 8, it's just a vertical angle to number 8. Right? So that would be false. All right, and then finally, what do we got? Number 9 says that in figure 2, EF plus FG is equal to EG. So you have a drawing right below on your Braille page of 302B, and we have E at the top right, and G at the top left, and then F at the bottom. And it says EG plus FG has to be equal to, or excuse me, EF plus FG has to be equal to EG. And that would be false, wouldn't it? because you just learned using your triangle inequality theorem it has to be greater than it in order to make a triangle. And finally, in number 10, next page, 302C, in figure 2, if FG is 5 and EF is 9, a possible measure for EG is 13.9. Well, we just learned in 7.4 we could add these together and have a number that's less than that, or subtract them and have a number that's greater than that. So 9 minus 5 is 4. We've got to have a number greater than 4. And 9 minus 5 is 14, so we've got to have any number less than 14. 13.9 is less than 14, so it would work. Doesn't always have to be a whole number. Don't assume that. All right, so that gets you through 1 through 10, and now we move on to reviewing each section, 7.1 through 7.4, with examples and problems. I'm going to go through the examples, and then you can work on the problems if you'd like. But I'll just go through each one of the examples, and you can make it work on those problems on your own, or maybe possibly we'll be working on them in class. So in 7-1, it just says apply inequalities to segments and angle measures. And it gives an example with a line with 3 points, 3 collinear points. You have a point on the left, point L, point in the midst, point N, and a point at the end to the right, point P. And you notice that LP is greater than LN, and LP is greater than NP. It's just reminding you that the entire segment has to be greater than any one of its parts. Likewise, on the next page, it reminds you that about angles. Same thing applies. So you have an angle, tactile, where you have B as your vertex on the right, and then you have 3 rays extending off of B. You have one that heads up to the right through point G, so you have a ray BG. And you have one in the middle, ray BH. And then you have one at the bottom, BK. And so you notice that we have a big, huge angle GBK, or KBG if you name it by the outside rays. That entire angle has to be greater than either one of its parts. So it's greater than GBH and it's greater than HBK. So it's just showing you that and reminding you that and giving you that in symbols. That the measure of angle GBK is greater than GBH and the measure of angle GBK is greater than HBK. So the next 11 through 16 have you figure out whether things are less than, greater than, or equal to, or true or false in regards to their inequalities. If you turn a couple pages to 303, it's a page break on 302D. It reviews the information from 7-2. It says lesson 7-2, identify exterior angles and remote interior angles of a triangle. And there's a drawing again, a tactile, a triangle with some extensions of the sides, little arrowheads extending the sides slightly to the top and left and bottom right. And then the outline you can make out is a triangle in the midst of it. The top vertex they're labeling U, and the interior angle is 2 and the exterior angle is 1. The bottom left vertex they're labeling it V. The interior angle is 4 and the exterior angle is 3. And the bottom right vertex they're labeling W, and the interior angle is 5 and the exterior angle is 6. So your interior angles are 2, 4, and 5. Your exterior angles would be 1, 3, and 6. And then your remote angles to each one of them, so angle 1, the 2 remote angles would be 4 and 5. To angle 6, the 2 remote interior angles would be 2 and 4. And the exterior angle 3, the 2 remote interior angles would be angle 2 and 5. And then recall from that particular, the next section, that you learned that if you add up your 2 remote interior angles, it's going to equal your exterior angle using that exterior angle theorem. So 17 through 20 just has you identify exterior and remote interior angles, the drawing. So you can work on those. And flip all the way to page 303B, and we're going to review the use of the exterior angle theorem with 7-2. So we're still in the same section. And it gives another graphic, and it's in the midst of the page. It's a triangle with the top extended to the right further to create an exterior angle. The top left is labeled C, top right vertex is labeled D, and the bottom vertex is labeled N. Your interior angles at N is number 4, at vertex C is number 1, and at vertex D is number 2. And then the exterior angle to number 2 at vertex D is number 3. So 3 is an exterior angle. What are its remote interior angles? They would be 1 and 4. And recall that you could add the measure of 1 and 4 together and get the measurement of angle 3. So it asks you if the measure of angle 1 is 75 and the measure of angle 4 is 35, what is the measure of angle 3? So you just say the measure of angle 3 equals the measure of angle 1 plus the measure of angle 4. You substitute in those values, 75 and 35, and add them together, and you discover that angle 3 is 110 degrees. So it goes through that little quick theorem on the next page on 303C, and then it has you practice the next few pages for number 21 through 26 until we get our way to 303D to review lesson 7-3 on page 303D. So on 303D, there's a triangle there. The top left vertex is S, the top right vertex is O, and the bottom right vertex is R. We go back up to S again. They have little arrow indicators indicating the measurement of the interior angle at S is 28 degrees. The interior angle at O is 121 degrees. And the interior angle at R is 31 degrees. And it's just identifying the relationship between the sides and the angles. This section just reviewed something we already kind of deduced on our own several sections ago when we were working with triangles, that the largest angle, the side opposite, is always going to be the largest side. So at angle O, it's 120 degrees, so we know the side opposite, SR, is the longest side. At angle R, vertex R, it's 31 degrees. That's the middle angle. So we know the medium side, the middle side, is going to be the side directly opposite, which is SO. And then the smallest angle at S is 28 degrees. So we know the side opposite that, OR, is going to be the smallest side. So it's just reviewing that. And then reviewing the converse. That would be on the next page, 303G. There's another triangle. J at your top vertex, K at the bottom right, and N at the bottom left. Back up to J again. And it gives you the sides, and then you would be able to name in order the largest angle to the least, or the least angle to the largest, whatever they ask you to do. From J to N on the left is 17. From J to K on the right is 11. And from K to N at the bottom is 14. So the largest side is 17, therefore the largest angle would be the angle opposite that. So on the left, JN, the angle opposite is K. So K would be the largest angle. The next side would be 14. That's NK or KN. The angle opposite NK is angle J. That would be the middle angle. And then finally your smallest side, JK, is 11. So the angle opposite 11 is angle N. That would be the smallest angle. So this lesson just had you identifying and putting in order, either from least to greatest or greatest to least, the sides or angles in comparison to whether you have the measurement of the sides or you have the measurements of the angles. All right. So that's 7-3, and 27 through 30 has you practice those. Get through those, and then you turn to page 304 straight up. That reviews lesson 7-4, which was using the triangle inequality theorem. And it's just determining if 15, 6, and 7 can be the measurements of the sides of a triangle. So the triangle inequality theorem says you got to take the two sides and make sure they're greater than, you add them together and make sure they're greater than that third side, and you got to do it 3 times. So 15, 6, and 7, you'd add the first two, 15 and 6, is that greater than 7? Yes. You add the first and last, 15 and 7, is that greater than the 6? Yes. You add the last two, 6 and 7, oops, that's 13, that's not greater than the leftover side, 15. So those 3 measurements would not work. And then you also can use the same information to figure out what possible measurements would work for any 2 sides by subtracting them and finding the least possible number, and by adding them and finding the greatest possible number. And you always have to be slightly above and slightly below those numbers. So that's 7-4, and there's several practice exercises 31 through 36 to practice that. Then there's a couple of application problems. So that's Chapter 7 review. Highly recommend that you listen to it, maybe listen to it again, and do some of the practice problems on yourself and come to class prepared to ask some questions and do some practice problems in preparation for the exam. All right, everyone, do good thinking. We'll see you in the next video.